today we're going to sort of add a little bit of vocabulary to what we've done, and we're going to add that last step into our graphing. But remember, that last step really isn't anything you haven't done before, because it's just solving like you've been doing last week. Okay? So we're going to tie it all together. We have a little bit of vocabulary. We'll do one example together, and then you can make the call. If you want to, we can do one off of your homework together. Otherwise, you would be set to work. So before we start, we have two new vocabularies for us. Although I'm going to give you three vocabulary, the first one's just not new. Okay? So number one is the x-intercept. What is an x-intercept? Yeah.
Point where it crosses the x line.
Yeah, that's going to be the point where we cross the x-axis. What do I know about that point?
Y equals 0.
Yeah, y is 0. So I'm going to have x comma some 0 for y. Remember that these are also called solutions and zeros. That vocabulary doesn't go away. So regardless of what they ask you for, if they're asking you for an x-intercept, a 0, or a solution, it's still going to be the same thing. Which is why, when we do this today, it's not anything different. In fact, I haven't given you anything different whatsoever except for our two little vocabularies. Okay? It's just sort of piecing everything together. Second new vocabulary is going to be the domain. Domain is all of the possible x values used in our equation. So here's my question to you. Do you have anything in mathematics that says you're not allowed to square certain numbers? No, there's nothing that says you can't square something, right? Is there anything in mathematics that says you're not allowed to multiply or add numbers? No, there's nothing that says that either. Which means that on all of our quadratics, our domain is very, very boring. Because on all of the quadratics, our domain is what we call all real numbers. Because you can plug it in anything you want to. You can't really plug it in an imaginary because I can't plot that on a number line. But anything that's real, you can do. You can plug it in, you can get a result out of that. It doesn't really matter. Okay? So on quadratics, it's all real numbers. On other graphs that we do for the remainder of the year, not always true. But on quadratics, like I said, that should be an easy answer for you. Vocab number 3 is going to be the range. And the range is all of the possible y values. In other words, these are all of your possible results in our equation. Now, when you're looking at your range, the trick for this is that normally on, again, all of our quadratics, range is either more than or less than the vertex. Because you're either going to gonna be a smiley face or a frowny face. So if I'm a smiley face, then all my possibilities are gonna be from the vertex up. If I'm a frowny face, then all of my possibilities are either gonna be from the vertex down. Okay? Questions there? All right. So then from here, what I'm going to do is I'm going to give you steps for graphing anything, no matter what format they give it to you in. We're going to change it just a little bit to make it a little bit easier given our new piece to our graph. Okay? Can I erase this? All right. So steps. We have steps for any of the quadratic graphing that we're going to do. Our first step is still going to state whether it opens up or down. After that, it would be a good idea to go ahead and look at the vertex. Now remember, the vertex is going to depend on how it's set up. In other words, if you're set up ax squared plus bx plus c, if you're set up in standard form, how do you find your vertex? I think I'm hearing it. Yeah, negative b over 2a would be the vertex. If you have that little parenthesis squared, well then your vertex is being shown as the h comma k. And then if you have those two parentheses that are being multiplied together, then your vertex is halfway between p and q. So that's kind of tying together everything that we've done up until this point. The third step is going to be to find the y-intercept. Y-intercept, remember that you're going to plug in x equal to 0, normally. Now our fourth step that we haven't really had to do is going to be to find the x-intercepts. X-intercepts, we said that we knew that the y value has to be 0. So now we're going to plug y equal to 0 and solve. And when we solve, we can solve by factoring. You can use the square root method. You can use the quadratic formula. Or if you prefer, you can complete the square. So all of those methods that you used in the last quiz are going to come back with you. And then finally, the last step is to go ahead and label your axis of symmetry. So like I said, we'll do one example together, and then if you want another one, we can do one off of your assignment for tonight. Okay? Can I erase these? So we're going to graph y equals 2x squared minus 4x minus 6. 1. So what's my A value? 2. So what does that mean?
That's positive.
Yeah, it opens up. Second step, again, a little bit out of order, is to do your vertex. How do I find the vertex on this type of a problem?
Your
Negative.
vortex.
Yeah, negative b over 2a. So we said a is 2, what's my b value?
-4.
So a negative of a negative 4 gives me positive 4 over 2 times 2. That's 4 over 4, which gives me an x value of a 1 for the vertex. Now what? How do I finish the vertex?
Plug in one for the x's.
Good, plug it in for the x's. Minus 6. So 1 squared gives me 1. I'm still seeing people messing up right here. You have to do your square first before you multiply throughout. So 2 times 1 is 2, minus 4 minus 6. 2 minus 4 is negative 2. Minus 6 gives me a negative 8. So that gives me 1 comma negative 8 for that vertex. Good so far? Alrighty, step number 3. Again, none of this is new. So step number 3 is the y-intercept. How do we do that? Yeah, you plug in the 0 for all of the x's. That gives me 0 minus 0 minus 6. So I get negative 6. Again, if you remember, if I'm in standard form, it's always going to be that back. So my y-intercept is 0, negative 6. Step number 4 is the x-intercept. Now on the x-intercept, you need to check to see if you even had one. So what that means is I'm going to kind of come off to the side here and I'm going to start graphing this problem out. And I'm coming up here since I don't want to erase this. So we'll graph 1, negative 8. And then I have negative 6. If I have a smiley face, am I going to stripe the x-axis?
Yes.
Yes. Yeah.
Put it as negative 1, negative.
I did what?
Put it as -1, negative
Oops, thank you. So if I'm going through and I'm looking, this is going to strike the x-axis, which means I can go ahead and do step 4. Now, if this was a negative 2 in front, so that I have a frowning face, would I be striking the x-axis? No, which means I could skip this step. So save yourself a little bit of work and double check it. If you're not going to strike the x-axis, there's no reason to look for x-intercepts. They don't exist. Okay? But I do have one, which means that now I can go ahead and find it. In order to find it, we're going to set the y equal to 0. And I'm going to solve using all of those methods that we've used before. So what's the first thing I should look for here? GCF. What is my GCF?
2.
Factor out of 2, and I get x squared minus 2x minus 3. Now what do I do with the parentheses? AC method. So what multiplies to make a negative 3, but if I add, I get negative 2. Yeah, so x minus 3, x plus 1 is the factorization. Notice when we went through, I didn't mention anything about this GCF all the way up to number 4 because it affects everything else. It does not affect your x-intercepts. That 2 does not have an x with it, which means I'm only setting the parentheses equal to 0. And solve. Add 3 to both sides, I get x is going to cross at 3. Subtract 1, I get that x is going to cross at a -1. So I go ahead and plot those 2 points. Go ahead and mark the axis of symmetry. What is the label for my axis of symmetry? Label, axis of symmetry, x equals 1. All right, how far away from my axis of symmetry is my y-intercept? 1. So I go 1 in the other way, and I have this complete picture of my quadratic. And that is everything. So there's nothing else that we can do with quadratics. Remember, your quiz on the quadratic is going to be Wednesday of next week. But that's it. They might ask you just simply to do x-intercepts. They might ask you just to do vertices. Or they might ask you to match a graph. Okay? But that's it. Now, there's something else that we start to look at when we start to look at our graphs. And so let me kind of get rid of this so that I can write this next to our graph here. And that is to go ahead and add to this the idea of our domain and range. So if they asked me for the domain here, what would my domain be? Yeah, it's all real numbers. On a graph, what that means is that if you look at this, these arrows are pointing all the way left and all the way right. So that means I'm going to cover the entire x-axis. There's no x value that's not going to have an answer for it. So it's all real numbers. My range, when we read range, we go from the bottom all the way up. So the first place that I have a y value is going to be right here at my vertex. And that's all the way down at -8. And then from there, all of my y values are bigger than that. Does that make sense so far? So then your range is going to be that all of your y values are either bigger than or equal to -8. Now, if it was a frowny face, then all of my y values would be lower than the -8. So I would have a less than sign then. So like I said, on a quadratic, you're either going to have the greater than sign because it's a smiley, or a less than sign because it's a frown. Questions with that? Questions? Yeah.
Is there ever an instance where the domain does not equal every x?
Not on quadratic. So quadratic is always equal to everything. Okay. So, and then they start to get a little weird also. So the last part that we're going to do is going to be the end of your worksheet. And that is, they'll ask you, as x approaches infinity, they're going to say y approaches length. Now, what are we talking about? Well, if I look at a number line, if I go all the way to the right, these x's are going to be all the way positive. So we call that infinity, marked with a sideways 8. If I go all the way left, we're talking about negative numbers, so we would call that negative infinity. Those of you who stopped taking notes, you might want to take notes with this because it will ask this on the quiz. On the y-axis, graphs that go all the way up, those are now going to be your big Y values. So that would be infinity. All the way down is going to be negative, so negative infinity. So if it's asking as the x values approach infinity, meaning as we travel to the right side, my graph is pointing up. Agreed? So if my graph is pointing up, I'm approaching what? Positive infinity. Now they'll try to confuse you by saying, okay, well let's change it. As x approaches negative infinity, y approaches, and then again blank. Yeah, so as I go all the way left, I'm still pointing up, which means I'm still approaching infinity. When is the only time I'm going to be approaching what we call negative infinity? If I have a frowny face. Notice that it doesn't matter whether x goes to positive infinity or negative infinity. They still approach the same because they're either both going to go up or they're both going to go down as you're graphing this. Does that make sense for that last bit of it? Like I said, that last bit is a little bit weird just because it's a little bit more mathy, but it does come into play after break, where we start talking about that sort of behavior of where are we pointing towards. Okay? All right, so let me give you your worksheet.